Hi all, welcome you all to Digital Communication Systems lecture series. In this video, we are going to study about what is communication and about the digital communication, the need for communication, and the components, advantages, and limitations of digital communication. First of all, we should know what is a communication. Communication is just transferring some information. If I am talking to you, I am sharing some information. So I need a source and I need a channel through which I can transfer the data, and there should be a receiver. So communication is a process of conveying some information from one location to the other location. So, for example, the information may be an image, it may be an audio, it may be a voice, or any type of data or video. There are two types of communication: analog communication and digital communication. For analog communication, the information will be analog and we will use analog modulation schemes. Say, for example, amplitude modulation, frequency modulation, phase modulation, and all will come under analog communication. Digital communication, we will convert analog to digital, and we will also use the digital modulation schemes like amplitude shift keying, frequency shift keying, and phase shift keying techniques. Talking about the block diagram of the communication system, this is general elements of communication system. We need a source of information from which a message signal, the actual information which we want to transmit, that will be sent to a transmitter, and from the transmitter it will be sent to a channel through which we are passing the information to the destination, and there will be a receiver, and the receiver will receive the signal and approximate estimate. Why we are telling this estimate of a message signal? It cannot be same as that of the source of the message signal which is sent, which is getting from the, which has been got from the source of information, because we are transferring the information through a channel. There will always be some error, some noise will be there, so it cannot be equivalent to the actual message signal. That's why we are giving the name estimate of message signal. Then it is given to the end user. What are the differences between the analog communication and digital communication? Here we can see the signal is in terms of continuous time, and here this is converted into a binary data. Here analog communication, the amplitude levels will be infinite, and here there will be only two levels of amplitude, zeros and ones, since we are converting from analog to digital. And the analog communication, always it is the noise interference will be very high. Here being digital, noise resistance is very high. And talking about the signal recovery cannot be done, it is not easy, but in digital communication it can be easily done because the noise is very less, the error is very less, so signal can be very easily recovered being the digital data. The application for analog communication includes radio broadcasting using the AM, FM, and PM. Digital communication finds a number of applications like video conferencing, mobile phones, internet, fax machines, and telegraphs, and television signal transmission. The security is very less in analog communication. Being less error, digital communication has got high secure, because we are going to use the data encryption and decryption, which will be known only to that particular transmitter and receiver. The error detection correction is not possible in analog communication, which can be made possible in digital communication, and the speed of transmission is very less in analog communication, and we can achieve high speed data with high data rate transmission in digital communication. Here comes the elements of digital communication. As we have seen for the normal general communication systems, we have a source of information from which we are getting the message signal, and these three sets are making the difference for elements of digital communication. We have a source encoder at the transmitter side, and in the receiver side, source decoder. Here channel encoder, channel decoder, modulator, and demodulator. This complete setup is available in transmitter. The inverse process will be done by these three sets in the receiver side. So source encoder will generate a source code word. Then channel encoder will create a code word which can be converted into a suitable form for transmission. Then modulator converts a waveform. Actually, modulation is done with respect to the carrier signal. Any of the characteristics of the carrier signal will be varied with respect to the message signal. So that after modulation, the modulated signal is sent through a channel, and after that The reverse process is done through demodulator, channel decoder, and source decoder. Finally, the estimate of message signal is received at the destination. Now in the source encoder, it's also called as a waveform encoder. So it's a kind of speech digitization which can be used for any other wired line communication. So the different types of waveform coding includes pulse code modulation, differential pulse code modulation, delta modulation, and adaptive delta modulation. In pulse code modulation, the message signal will be represented in terms of some coded pulse. Here we can see from the telephone we get analog audio source, then sampling is done. After sampling, the quantization is done. Here in the sampling, we will convert all the signal, input signal, into the discrete level only in coordinate values, not in the amplitude. But in quantization, we will convert both the amplitude as well as the coordinates in discrete value. So the pulse code modulation is represented, the signal will be represented in terms of some sequence of coded pulses. In differential pulse code modulation, the samples are compared and the difference between the samples will be sent as codes. And in delta modulation, there will be only one bit will be transmitted per sample. Adaptive delta modulation, we can change the data based on the step size. So which we have discussed now. From the analog signal, we come to the sampling, quantization, and encoding. Here we are ensuring the security. Encoder ensures the security of data. Then after encoding, the digital data is converted in terms of zeros and ones. We can see after sampling, the analog signals will be converted into discrete in time, but still the amplitude will be continuous. After quantization, both amplitude and the coordinate values will be converted into discrete. So converting from discrete time continuous valued signal to discrete time discrete valued signal is called quantization. In the channel coding, there will be so many errors from before we transmit. So the channel coding will protection will be done against the transmission error by having a selectively inserting some redundant information. Redundancy means repetition. Some repeated information can be automatically added to the signal so that the channel encoding ensures the protection for the signal. And modulation, as we all know, we will use both the message signal as well as the carrier signal, which is having a high frequency compared to the message signal for suitable form for transmission. So here we have a different type of modulation schemes: ASK, FSK, and PSK. ASK has got this is a binary data. Say for example 0110101. This is going to be the binary data. Now if it is an amplitude shift keying, we can see only for transmission of 1 there will be signal existing. For 0, no data, no signal is available. So only the amplitude, we are getting the amplitude only when the 1 is transmitted. For phase shift keying, when there is a transition from 0 to 1, you can see it's going from positive. And for one transmission, and from 1 to 0 and 0 to 1, there is a change in signal. Okay. And for frequency shift keying, we can see for one transmission, the time difference is very small. That means the frequency is higher. We have high frequency for one transmission. We have low frequency for 0 transmission. What is the difference between the baseband and passband transmission? Baseband transmission is the signal is sent as such without any modulation. And there is no need for carrier wave, because only for modulation carrier wave is required, and the baseband transmission is used for short distance communication. Compared with the baseband communication, passband transmission, this will modulate the digital data using a high frequency wave, and of course we need, since we are using modulation, carrier wave is required, and this is used for long distance communication. What are the advantages of digital communication? So we have seen earlier, this is highly immune to noise, highly reliable, the quality is improved, the error detection and correction is possible, transmission is easy and faster, multiplexing can be done, and communication is very, very secure. The limitations of digital communication is, since we are converting from analog to digital conversion, the data rate is high. That is one of the advantages. Because of the high data rate, we require the high transmission bandwidth or high channel bandwidth. And of course, since we are using the carrier signal both at transmitter and receiver side, synchronization is very, very important. These are the limitations of digital communication. So that's all about our first video. We have studied about the digital communication, the need for digital communication, the elements of digital communication, and the advantages and limitations of digital communication. Thank you. We shall all meet in the next video.